Today, Zmotion brings simple parameters and commands that are used usually in your development and application. First of all, basic materials are needed. Others depend on your actual requirements. Generally, wire them like this. But specific controller model, better to read the manual. According to the functions, parameters and commands are introduced from 4 parts. Axis parameters used, usually. Special input maps related to axis. Axis state checking. And single-axis motion commands. And here, let's see the first part, axis parameters. It can be seen there are some, and they should be configured in initialization. Next, one by one. Base. It is used to select axes. Starting from axis 0 to the max number of controllers -1. For example, if the controller has 32 axes at most, then we could select from 0 to 31. That is, we need to know how many it supports. There are 3 ways: through controller state, or hardware manual, or asterisk base. But please note, it can select several axes at the same time. That is, base is mainly for one axis or axes. If one single axis, set for this axis only. If there are several axes, set them each one independently. Because basic program motion generators that controls axis motions are separated. Each motion generator has its own function. Like this, below parameters are related to each axis. Each axis has its specified speed, acceleration. In addition, axes can be connected together through superposition motion, synchronization, or interpolation. Then, the speed of interpolation uses the main axis parameter, namely the first axis of base. A type. It is used to set axis type. This form shows the main types, and only the types that controller supports can be used. That is, if the controller is pulse type. Please set a type as 1. If the pulse axis expanded by Z can expansion module, please set it as 8. For EtherCAT bus axis, set it as 65, and they should be configured in initialization, even if the axis types must be matched correctly. It also supports interpolation between different axis types. That is, bus axis and pulse axis can do an interpolation motion. If there are several axes, also can set them together, like this, or write several commands to specify corresponding axis. Units means pulse amount. Controller takes units as the basic unit, then specifies the number of pulses to be sent in each unit. The precision can be up to 5. Now, it can be known units connects user units and pulse units. For example, when units is 10,000, move to means giving 20,000 pulses for motors. If the motor doesn't have the machine loaded, the number of revolutions of the motor depends on how many pulses needed for motors in one circle. There shows 3 examples to know clear. If the motor needs 10,000 pulses for 1 revolution, move 3 makes the motor turn 3 times. Then, set units as 10,000. If it needs 2 to the 17th power pulses for 1 revolution, move 2 makes the motor turn 2 times. Then, set units as 2 to the 17th power. If it needs 10,000 pulses, and this motor connects to 1 lead screw of 10 millimeters, which means sending 1,000 pulses, the screw will move forward 1 millimeter. If set units as 1,000, move 5 will move forward 5 millimeters, and give 5,000 pulses for motor. Let's see more. Suppose motor sends 3,600 pulses in 1 circle. Then units should be 10. And move 1 will send 10 pulses, turning 1 degree. Still 3,600 pulses, but here is 1 screw. Corresponding screw moves 1 pitch to millimeters. At this time, units should be 1,800. So move 1 means workbench moves 1 millimeter, sending 1,800 pulses. Please note if there is deceleration ratio, it should be calculated together. If deceleration ratio I is 2 to 1, Now, it needs 3,600 pulses for 1 millimeter. That is, deceleration ratio is bigger. Units is bigger also to reach needed position. Speed, axis running speed. The unit is this. That is, how many pulses to be sent for each second. Acceleration, speed reached in each second. If the acceleration is bigger, the time to reach speed will be less. Deceleration, same as acceleration. But please note when deceleration is 0, it equals to acceleration value. And all these will be valid immediately. Please set them in initialization. Generally, we use oscilloscopes to capture them to see trajectories. And the speed curve shows them all. Acceleration, speed, deceleration. As before, we had talked about oscilloscopes. Please go to Motion Control Start 9. S-curve settings in acceleration and deceleration. S-curve is too smooth. Here shows the usage. The time can be set from 0 to 250 milliseconds. When it is 0, it belongs to the T-shaped curve. It is only for speed curves. Others remain. When it is set as other values, it is S-shaped curve. Speed curve will smooth correspondingly. Then it can reduce shakes in on, off, and acceleration and deceleration. Even if the value is more than 250 ms, it still uses 250 milliseconds. Here is one example. It can be seen axis 0 is T-shaped, axis 1 is S-shaped. Obviously, axis 1 is smoother. Fast deck, emergency stop deceleration. It is used automatically when in cancel, rapid stop, or arrives position limit, or stops abnormally when the set value is 0 or smaller than decil. It uses deceleration values automatically. Here, one example. And this shows the situation when fast deck is 2000. And this, it is 0, so deceleration value 500 is used. Creep speed when axis homing. Used for origin findings. Please refer to the data command behind. Speed, axis starting speed, also is end speed. Default is 0. When there is multi-axis motion, after setting for main axis, it can be starting speed for interpolation motion and usually used for applications that needs efficiency. For example, set 40 for main axis 0. And this 40 is also used for other axes in interpolation, like axis 0, axis 1. That is, starting speed and end speed of axis 0 and axis 1 both are 40. Axis, used to modify one motion command or one axis parameter to specified axis. It only needs to add it behind the command. Please see examples. First one means it prints measurement position of axis 3, not the main axis of base. In other words, if there is no axis command, main axis MPOS will be printed. And these are the same principles. DPOS, axis virtual position or demand position, used to see the running situation. And when DPOS value is modified, motor will not move. MPOS, axis measurement position, used to see encoder feedback position. When there is no encoder connected, MPOS equals to DPOS. Merge, used to open or off continuous interpolation. Specifically, it connects front buffer motion and back buffer motion. No deceleration among several continuous interpolations. Then, processing efficiency can be promoted. If it is off, it will decelerate to 0, then reaccelerate to execute next interpolation motion. In this routine, set to linear motions. This one is on, it can be seen no interrupt. This one is off, it can be seen here stop and restart again. If there is still deceleration when it is on, we could check through these aspects. First of all, confirm whether the controller supports the function. If the controller only supports simple functions, like point to point, which means it can T-support continuous interpolation function. Secondly, in Axis Parameters window, see whether merge command is on. Thirdly, corner mode is set at the same time. Fourthly, commands that are used with SP, and these two are set, because speed is also determined by them. Fifthly, main axis changed in the process. That is, main axis speed changed also. The last one, delay command in buffer, is added. Even if it sets as 0, deceleration also appears. Okay, today's 14 basic axis parameters are introduced. Let's see in second part. Have a nice day.